Hi, Dr. Zamri. I am Guhadarshini Selamuttu. So today, my title on the new trends of cloud computing security will be on securing cloud system in the pre-quantum era, the potential challenges and solutions. So before we go into the topic, let's do some introduction. Cloud security is essential in today's digital environment as organizations progressively depending on the cloud services for data processing and storage. The current encryption techniques developed in the cloud environment may be threatened by the development of quantum algorithms, needing the development of new data protection measures. This presentation shows how we can strengthen the current cloud computing security, the steps to protect the cloud data as a preparation before we enter into the quantum era, the potential challenges and the potential positive impacts on the cloud security during the quantum era. Let us look into the difference between quantum computing and classical computing. So, classical computers, which employs bits that are either 0 or 1, whereas quantum computing uses qubits for parallel processing and can solve complicated problems a lot faster. Now, let's look at why cloud computing security is important. Due to scalability, lower prices, and simpler management, businesses or organizations are depending more on cloud infrastructures for their data processing, application, and storage needs. Security issues such as possible data breaches, the distributed denial of service (DDoS) attack, and insider threats are increasing along with cloud usage, which demands robust encryption and security measures. Organizations must spend in safeguarding their cloud environments because inadequate security raises the possibility of unauthorized access to sensitive data stored in the cloud. If cloud environment is not secure, sensitive data can be vulnerable to unauthorized access. Therefore, investing in robust security measures is critical to safeguard cloud infrastructure. Let's look into in detail. Data encryption. Example, advanced encryption standard to protect sensitive data stored on cloud. Secure socket layer and transport layer security to encrypt the communication between client server and to protect data over network. Second, network security. Virtual private network by protect data in transit while intrusion detection system ensure ongoing monitoring and threat detection. Third, endpoint security. Example, mobile device management to monitor device, endpoint protection platform, firewall and antivirus to protect from malware. The fourth one, identity access management, IAM. Example, multi-factor authentication, role-based access control, and least privilege principles to administrate and authorize who can take action on specific resources. And the fifth one is zero trust architecture. Example, strict authentication, access control monitoring, detect insider threats, and mitigate potential damages. Now, let's look at the latest trend to secure cloud computing. First, zero trust security model. It is used to identify base access control and microsegmentation mitigation attack surfaces. 2. Blockchain security model to assure tamper-proof logs and data integrity. CSPM, which is Cloud Security Posture Management. It's a tool to identify misconfiguration before they become vulnerable. TEE, Trusted Execution Environment. It's used to secure data while it is being utilized or used, not only when it is in transit or at rest. The artificial intelligence and machine learning, which is uh, used to identify threats in real time. Next is the Cloud Workload Protection Platform, CWPP, to ensure compliance and availability. The last one will be hardware security models, which is a biometric based authentication without using a password authentication. So, since we are looking at the latest trends, cloud security with quantum computing is also one of the latest trends. To prove this, I've written an article published by the IEEE Computer Society written by C. Joseph, which the article pointed about the integrating quantum issues into an organization's cloud security planning is a trend now or becoming very important. Additionally, the article also explores the problems and fixes related to cloud security in the quantum era. Let's look into it in more detail. By successfully combating today's threats, we can create the groundwork for a more seamless future transition to quantum resistant protection. How to secure the current cloud security? Let's look at it. So, these are the measures form a secure foundation for cloud security, but quantum computing may challenge their effectiveness. So we have to look into the steps to be taken to protect the data in the pre-quantum era, which is now. So some of the steps are more to the cloud service providers, such as they must take proactive steps to integrate quantum-resistant encryption algorithms for data at rest and data in transit into our cloud infrastructure to stay ahead of future threats. Next is to keep an eye on developments in quantum computing and cryptography, so cloud security protocols can evolve accordingly. And cloud service providers also should collaborate closely with researchers in cryptography to make sure their platforms are protected from dangers posed by quantum computing. Now let's look at the potential challenges in quantum era that we may face by using the current cloud computing security. Current cloud computing security will be at risk once quantum computing becomes a reality. How? Data encryption. The Shor's algorithm, which is the quantum algorithm designed to solve the integer factorizations, allow quantum computers to crack popular encryptions like RSA, which is currently in use in our current cloud computing system. Next, in terms of network security, the public key cryptography used in secure socket layer and transport layer able to decrypt intercepted network traffic. Example, even when VPN may be vulnerable to eavesdropping by attackers with quantum capabilities. Next is the IAM, the public key infrastructure for authenticating may compromise by quantum attackers, which could easily imitate digital signatures or crack the encryption required to verify users' identities. Okay, now let's look into why we have to be prepared before quantum computing takes place. As I read in the article in Faster Capital, it says that quantum computing in the cloud is one of the emerging trends in cloud computing. So which means we have to be prepared for the potential effects as well. Okay, now let's us look into the real world case study, the IBM. IBM is working on quantum safe cryptography, which enable cloud services to remain secure in both classical and quantum attacks. The classical here refers to the current state of the cloud computing. So, what it says that IBM's Quantum Safe is an end-to-end solution that will assist enterprises and government agencies in identifying and replacing existing cryptography algorithms with new algorithms. Quantum Safe includes a comprehensive set of tools and capabilities to assist in transforming to an environment that can resist quantum threats. Example of the algorithm which IBM working on is the Kyber, a lattice-based cryptography, which offers new secure key exchange protocols that shield cloud services from quantum attacks while enabling them to exchange encryption keys securely. Although the developing quantum computing may give a lot of negative impacts on cloud security, but it also gives potential positive impacts. Example, it may improve a rapid identification of threats. Example, a rapid detection and a response time. Next, the principles. Examples, the developing of quantum key distribution algorithm may allow secure data transfer and shield provide cloud information from online attacks. The developing encryption system post-quantum cryptography would make safer cloud environment even when faced with threats from quantum computing. Cloud infrastructure use quantum error correction techniques to guarantee fault tolerance in such distributed systems continue to function even in the face of malicious attack or extreme network traffic. So conclusion, practically, quantum computer research is still in its early stage, and before they can seriously threaten cloud security, several technical challenges need to be addressed. Although quantum computing poses a serious threat to cloud security, it also creates new opportunities for more robust, secure encryption. We have to strengthen today's cloud security in order to be prepared and safeguard for the quantum era. Thank you. These are the references to build this presentation. Thank you.